Hi students, welcome to today's class. I hope that you are all preparing well for your JEE mains examination, which is going to commence from April, that is a second shift. Then in this video, I am going to explain very important problems which were given in the completed JEE January shift. Okay, now. So let us see the first problem. So here f of t is given by integral 2t upon t square plus 1 into t square plus 3 dt, where the value, find the value of f of 4. So we have to find out the value of f of 4. F of 4, given that f of 3 is equal to ln 5 minus ln 6 by 2, logarithm of 5 minus logarithm of 6 by 2. Okay, now then how to do this problem? This, whatever may be that this type of results given, that is useful for finding the constant of integration. Okay, now first let us take the given problem. So here integral of 2t by t square plus 1 into t square plus 3. What do you observe here? What is the derivative of t square? 2t. What is the derivative of t square? 2t. Understand this? So first thing what you have to observe means it is a substitution type of problem. Therefore, put t square is equal to some u. So this is a 2t dt is equal to du. Now our f of t will become integral 1 by 2t dt is tq. So t square is equal to u plus 1 into u plus 3 du. Understand? Clearly this is a partial fraction. So then how do you will divide the fraction? 1 by u plus 1 minus 1 by u plus 3 du. See in the numerator what you will get here? U plus 3. Here cross multiplication, minus u minus 1 plus u minus 1 cancel. 3 minus 1 2. So 3 minus 1 2 means what? This is 1 by 2. Understand? This is 1 by 2. Okay, right. So this is clearly, so this is a ln of u plus 1 minus ln of u plus 3, of course, plus c, constant of integration. Understand? Now let us change this problem into t. So this is equal to 1 by 2 into ln of u means how much? T square plus 1 minus ln of u means how much? T square plus 3 plus c. So this is the f of t. So your f of t gone. So this part is over. Now we have to find out c. To find out c, what is given? f of 3 is equal to ln 5 minus ln 6 by 2. So wherever t is there, substitute t is equal to 3. T is equal to 3. So this is equal to f of 3. So f of 3 means how much? Ln 5 minus ln 6 by 2 is equal to 1 by 2 into ln of t square plus 1. T square is equal to how much? T square means how much? 3 square, 9. 9 plus 1, 10. 10 minus ln of 3 square, 9. 9 plus 3, 12. Plus c. Plus c is there. Now, so see here, this is equal to 1 by 2 into, this is ln of log a my 10 by 12 plus c. This is 1 by 2 ln of 2 5s are 2s are 5 by 2 plus c. So this is also how much? 1 by 2 ln of 5 by 6. Understand? So these two will be get cancelled. This and this will be get cancelled, and we will get c is equal to 0. We will get c is equal to 0. Therefore, finally, what is your f of t is equal to 1 by 2 ln of t square plus 1 by t square plus 3. 1 by 2 ln of t square plus 1 upon t square plus 3. Now, f of 4 is asking. So this is equal to f of 4 is equal to 1 by 2 ln of 4 square 16. 16 plus 1 how much? 17. 4 square 16. 16 plus 3 19. So this is equal to 1 by 2 ln of 17 by 19. 1 by 2 ln of 17 by 19. That is the correct answer. Okay, so very easy problem. This is the only first thing what you have read. So here t square 2t is there, t square 2t is there. So substitute t square is equal to u or something other variable, then the problem will be very easy. Okay, now so I hope that you understand this total solution. So let us move to next problem. Hi students, welcome to this problem. So the coefficient of x to the power of 301 in this binomial expansion. Now I am writing this binomial expansion clearly. So here 1 plus x whole to the power of 500, x into 1 plus x whole to the power of 499, x square into 1 plus x whole to the power of 498, plus so on, x to the power of 500 into actually 1 plus whole to the power of 0. Understand? Let it that. See the observe here, this is x power 1, this starts with x power 0. Observe the first terms here, x power 0, x power 1, x square, x cube, so on, x to the power of 500. Second factors, 1 plus x whole to the power of 500, 1 plus x whole to the power of 499, so on 498, last 1 plus x whole to the power of 0. So in this we have to find out the coefficient of x to the power of 301, x to the power of 301. Clearly in this we will get the, so x power 0 means I will leave it here. What is the coefficient of x to the power of 301? So clearly this is a 500c 301. So what is the 500c 301 is equal to x to the power of 301 will come, x to the power of 301. So this is the coefficient. Coming to here in this term, already x is outside. So if it is enough, if you find out the coefficient of x to the power of 300, x to the power of 300 coefficient is enough. Why? Because x is outside, x into x to the power of 300, x to the power of 301. Understand? So what is this coefficient? So this is equal to 499 c 300. Understand? 499 c 300 will how much? X to the power of 300. Okay, right. In this already x square outside is there, no? So it is enough if you find out the coefficient of x to the power of 301, no? So 301 means 299 plus 2, 301. So this is given by how much? 498c 299. If you go on doing, so where will be you end? Where it will end. So if you observe here x square, so if you here you will get the coefficient of x to the power of 500. No, so center in between. So in between you will have, so this is a x to the power of some 300 you will get, no, definitely. So x to the power of 300 into 1 plus x to the power of 300 plus 1 by x, definitely somewhere you will get x, no. So 2 plus 498 is equal to 500, no. So definitely you will get 200 here. See here, observe here, 500, 1 plus 499, 500, 2 plus 498, 500. So x to the power of 300 into 1 plus x whole to the power of 200 you should get, no. So here if you find out the coefficient of x, that is enough. Coefficient of x. Why? Because already x to the power of 300 is outside. So this is equal to how much? 200c. What is the coefficient of 200c? 1 plus x whole to the power of 200. No, 200c 200. 200c 200. How much you will get? X to the power of 200 you will get. Last term, x to the power of 200. So not, so already x to the power of 300 it is there, no. It is enough if you find out the x coefficient is enough. X coefficient. What is the x coefficient means? 200c1. 200c1. That is the 200c1. Previous term what will be there? Previous term what should be there? So here what will be there? X to the power of 299 into 1 plus x whole square. So here what you will get whole square this is equal to 299 previous term. How much 500 you have to get? No, 500 means how much? 202. 202. So how much here? 201. Sorry, 201. So 201, 299. So how much this is? So here what will be the last term? Already x power 300 is there. One more term also will come, that is x power 301 into 1 plus whole to the power of 299. Understand? 301, 199. So this is 199. Understand? So 301 plus 199, 500. So here what is the coefficient? So here what is the, here already x to the power of 301 is there. Here no need of any one more term. Why? Because already x to the power of 301 is there. We want x to the power of 301 is only. What is here? We will get 199C0. 199C0 we will get. Okay. So let us add all these terms. Okay. So that we will get the coefficient of x to the power of 301. So this is equal to 500C 301 plus 499C 300 plus 498C 299 plus so on last terms 200C1 plus 199C0. See here NCR. N's are different. N values are also different. R values are also different. This type of problems can be done using the formula NCR plus NCR minus 1 is equal to N plus 1 CR. Now what you will do now, in here 199C0 is there. No, you write down 200C0. No problem. Why? Because 199C0 value is 1, 200C0 is value is also 1. Why we made this means here N, R minus 1. N will become N plus 1, R minus 1 become whichever is bigger, that will come. So if you combine these two, so what you will get here? 201C1. So this is a previous 21C2 is there. Again if you combine these two, how much you will get? 202C2. Like that, if you go on combining like this, so you will get 500. So how much you will get? So 501C301. So 501C301. So this will be the coefficient of x to the power of 301 in the given terms. Okay na? So very logical problem on the binomial theorem. So I hope that you understand this solution. So let us move to next problem. Hi students, welcome to this problem. Very easy problem. This is from vector algebra. If A bar, B bar, C bar are three non-zero vectors such that n cap is perpendicular to C bar. Here n cap means unit vector which is perpendicular to a vector C, and A bar is equal to alpha B bar minus n cap, alpha B bar minus n cap, where alpha is not equal to 0, and B bar dot C bar is equal to 12. B bar dot C bar is equal to 12. So there are different number of information is given. Then the value of modulus of C bar cross A bar cross B bar is equal to how much? See here, first of all, this we know immediately. This is a vector triple product. Vector triple product. What is a vector triple product? So this is equal to C bar dot B bar A bar minus C bar dot A bar into B bar. So this is the right. So let us check whether any information is given, right? Here B bar dot C bar is equal to 12 is given, right? Anything, and here C bar dot A bar, nothing. So yes, B bar dot C bar is equal to 12 given. So up to here it is a, so 12 A bar minus, this is a C A bar dot, this is a B bar. Understand? Right. Now let us see here. Anything we can substitute. Now let us see this information. So let us see this data. So that is equal to, it is given that A bar is equal to alpha B bar minus n cap this is. Okay, so this is a bar plus n cap is equal to alpha B bar. Okay, now our aim is to find out C bar dot A bar. Then what shall we do? So to get this C bar dot A bar, let us do the dot product with the C bar. Let us see that. So this is equal to C bar dot A bar plus C bar dot n cap is equal to alpha into C bar dot B bar. C bar dot, C bar dot, C bar dot. Alpha is a constant. So here C bar dot A bar plus C bar dot A bar, C bar dot n cap is equal to how much? See here, these two are perpendicular. N cap is perpendicular to C bar. Therefore, their dot product is equal to 0. So, two vectors are perpendicular. Their dot product is equal to 0. So, let us forget about this. So, this is a alpha into C bar dot B bar. C bar dot B bar is equal to how much? 12. So, this is 12. Okay now. Now, let us substitute those values here in this equation. So, this is equal to 12 A bar minus C bar dot A bar is equal to how much? So, here C bar dot alpha into C bar dot B bar. All right. So, C bar dot A bar is equal to how much? Alpha into 12 into B bar. Okay now. So, what can we take common outside? 12 we can take common outside. So, this is equal to 12 into A bar minus alpha B bar. A bar minus alpha B bar means how much? Let us see here in this equation. A bar is equal to alpha B bar minus n cap. Take alpha B bar to left hand side. A bar minus alpha B bar is equal to minus n cap. So, this is equal to 12 into minus n cap. So, this is a 12 into 1, that is a 12. Why? Because so n is a unit vector. N cap means it is a unit vector. So, modulus of n cap is equal to 1. Of course, minus will go. So, ultimate answer is 12 is the final answer. So, this was the problem given in the latest January examinations. So, first thing what you have to write down, you have to write down the vector triple product and substitute the values. And we have to find out C bar dot A bar. Let us take the given relation. So, to get C bar dot A bar, what you have to do? So, multiply with C bar dot C bar dot whole thing. So, we will get C bar dot A bar is equal to substitute here, take 12 common, again minus n. So, like that, step by step, you will get the answer. Okay now. So, I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So, this is also from binomial theorem. If AR is the coefficient of x to the power of 10 minus r, x to the power of 10 minus r in the expansion of 1 plus x whole to the power of 10, then find the value of sigma r cube into AR by AR minus 1 whole square. So, let us see this problem. It is a binomial expansion. When binomial is given that 1 plus x whole to the power of 10. What will be the coefficient of x to the power of 10 minus r? So, where you will get x to the power of 10 minus r, you will get, where you will get? So, we will get here 10 CR. So, 10 CR value, 10 CR into x to the power of 10 minus r. Okay now. So, this is given as AR. Therefore, AR is equal to 10 CR. Understand? AR is equal to 10 CR. Now, what is AR minus 1? 10 CR minus 1. Therefore, AR by AR minus 1 is equal to 10 CR by 10 CR minus 1. So, in the binomial coefficients, we have formulas that is equal to NCR upon NCR minus 1 is equal to N minus R plus 1 by R. Here also the same story, R minus 1. So, this is equal to 10 minus r plus 1 by r. So, this is 11r by r. 11r by r. Now, let us substitute in that. So, this is equal to sigma r cube into, so this is equal to 11 minus r by r whole square. This implies sigma here, r runs from 1 to 10 only, r runs from 1 to 10. If it is there not given, we can find out the bounds. Why? Because 1 plus x whole to the power of 10. So, the maximum what we will get, r is equal to 10. Understand? So, r runs from 1 to 10. So, this is equal to r square, r cube by r square gets cancelled. So, this is r into 10 minus r whole square, r into 10 minus r whole square. So, you can do this problem very easily. So, by how to do this? So, that is equal to 10 minus r whole square, expand it, 10 minus r expansion we can do, and multiply r inside. But without doing that also we can do a short trick method. So, that means replace r with 10 minus r. So, not 10 minus r. So, this is equal to 11 minus r. So, this is 11 minus r. Replace r with 11 minus r. Then what will happen? So, this is equal to sigma r runs from 1 to 10. So, this is equal to 11 minus r whole square into r square. So, 11 minus r into r square. 11 minus r into r square. Both values will give the same. So, this is equal to sigma r runs from 1 to n. So, this is equal to 11 r square. Sigma r runs from 1 to 10. This is gives you r cube. So, this is 11 into sigma r square. Sigma r square means n into n plus 1 into 2n plus 1 6. Here n means 10. 10 into 11 into 21 by 6 minus 10 into 11 by 2 whole square. So, you calculate this 1 to 1. So, this is equal to 1 to 1 0 you will get. Understand this? Okay. So, I hope that you understand this problem. Okay. So, let us move to next problem. Hi students, welcome to this problem from inverse trigonometric functions. The sum of all the solutions of a inverse trigonometric equation is given. So, that is a tan inverse of 2x upon 1 plus x square plus cot inverse of 1 minus x square by 2x is equal to pi by 3. Then, and also given that x belongs to minus 1 to 1 is alpha minus 4 by root 3, then alpha is equal to how much? Here, one trigonometric, inverse trigonometric function is given. So, that is equal to, what is that? 1 second I am writing. So, this is equal to 1 minus, so this is a cot inverse of 1 minus x square by 2x is equal to pi by 3. Understand here. So, here the interval is from minus 1 to 1. See here, when x belongs to minus 1 to 1, then this inverse trigonometric functions behaviors will change. So, I will divide this interval into negatives and positives like this. So, here case 1 I will take minus 1 to 0 and case 2 I will take 0 to 1. So, when x belongs to 0 to 1, when x belongs to 0 to 1, very clear, all formulas here. Tan inverse of 2x by 1 minus x square is equal to 2 tan inverse of x. So, this is equal to 2 tan inverse of x plus, see here, cot inverse of 1 minus x square by 2x. So, this is also reverse is there, no? 2 tan theta by 1 minus tan square theta. Understand? So, this will become, so this also 2 tan inverse of x will become, this is equal to pi by 3. Understand this? So, 2 tan inverse of x, 2 tan inverse of x, so 4 tan inverse of x. Therefore, tan inverse of x is equal to pi by 12. So, therefore, x is equal to pi by 12. That means tan 15 degrees 2 minus root 3. So, one value we got, x is equal to 2 minus root 3 we got. Okay, na? So, put it like that. Put it like that. Now, coming to this second case, when negative is there, so this will become tan inverse of 2x by 1 minus x square, no problem. So this when x belongs to minus 1 to 0, x belongs to, of course, so this is equal to 2 tan inverse of x. 2 tan inverse of x, tan inverse of 2x by 1 minus x square is equal to 2 tan inverse of x. When x belongs to minus 1 to 0, remember that this will become 2 tan inverse of x, but pi will be added. 180 will be added. So once you go through the properties, pi plus pi will be added when x belongs to minus 1 to 0. Okay, now? So this is equal to pi by 3. So once you go through the so 2 tan inverse of x, 2 tan inverse of x, this is equal to, now tan inverse of x is equal to pi by 3 minus pi, pi by 3 minus pi. So this is equal to 3 pi. Pi minus 3 pi minus 2 pi by 3 into this 2 will come here. Understand? 2 plus 2 here 4 will come. So 2 1s are 2 2s are minus pi by 6. So pi by 6. Therefore x is equal to how much? Minus 30. Tan 30 means 1 by root 3. So this is 1 by root 3. This is another solution. Another solution. So first solution, second solution. He is giving that sum of the solutions is equal to alpha minus 4 root 3. So let us add these two solutions. That is 2 minus root 3 minus 1 by root 3. 2 minus root 3, how much here? Root 3, 3, 3 minus 1, 4. 4 by root 3. This is given as alpha minus 4 by root 3. Therefore, if you compare both the values, alpha is equal to 2. Understand this? So this is the solution of the problem. The one first thing what you have to do, so observe the here domain minus 1 to 1 is their domain. That's divided into two parts. When x belongs to 0 to 1, that is the positive values. So everybody knows that. When x belongs to negative only, then pi you have to add. So once you go through the properties of inverse trigonometric functions, there are number of formulas are there. So if you go through those formulas, this problem will be very, very easy one. Okay, na? So let us move to today's maths Olympiad problem. So the problem which I am going to explain is a very, very easy one. So but it was given in maths Olympiad. Okay, so let us see that problem. Hi students, welcome to this maths Olympiad problem. See the problem. Solve 2 power a plus 2 power b plus 2 power c is equal to 2320. So we have to find out a value, b value, c value. Generally we have an opinion that the number of unknowns should be equal to the number of equations. Here number of unknowns are how many? 3. What are they? A, B, C. So we have to find out the values of A, B, C. Of course you can put X, Y, Z also, no problem. That means we required 3 equations. We required 3 equations connecting A, B, C. But here we have one and only one equation. Then how to solve A value, B value, C value? Okay, if options are given, then we can do option verification. Okay, by substituting A value, B value, C value, then we will get the sum and we will get the answer 2320. But here options are also not given. So they are simply given A is equal to dash, B is equal to dash, C is equal to dash. How to do this? So here how much base is there? 2, 2, 2. First let us try to write down the right hand side as a base 2. Let us start. Generally in the lower classes we will do that. 2320 into 2 times. So see here 2 1s are 2 1s are 2 6s are 0. Again 2. 2 5s are 2 8s are 0. Again 2. 2 2s are 2 9s are 0. Again 2. 2 1s are 2 4s are 5. 145. Put it like that, 145. So this is equal to 2 power A plus 2 power B plus 2 power C is equal to 2 power 2 into 2 into 2. This is equal to 16 into 145. 16 145s are. So clearly this is a even number, it is odd number. It is a even number and odd number. Okay. Here what you will do now, though multiply and divide this equation, multiply and divide with the equation with the 2 power a. Here 2 power a by 2 power a is 2 power a. Can I do it? Multiply and divide with the 2 power a, 2 power a, 2 power a. So now this is equal to 2 power a into 2 power a, 2 power a will get cancelled. A power m by a power 1, b minus a, 2 power c minus a is equal to 16 into 145. Clearly 2 power a is a even number, this whole is a odd number. Even number, odd number. Why? Because even though these two are even, plus 1 you are adding, then it will become add. Therefore, we can see simply 2 power a is equal to 16, 2 power a is equal to 2 power 4, a is equal to how much? 4. Luckily we got a is equal to 4, and this is a 1 plus 2 power b minus a plus 2 power c minus a is equal to 145. 2 power b by 2 power a, again I write down 2 power c by 2 power a is equal to 144. 144. Understand here? Now 1 will go 144. Again 2 power a also will come. 2 power a means what? 2 power 4, 60. That means 2 power b into 2 power b is equal to 144 into 60. Sorry, here plus. So 2 power b plus 2 power c is equal to 144 into 60. Then let us try to write down 144 into 60. So this is equal to 144. First 2. 2 7s are 2 2s are 2 36 are 2 18s are 2 9s are, that's all. So this is equal to 2 into 2 into 2, 16. That means 2 to the 1, 2 to the power of 4, already 2 to the power of 4 into 9. 2 to the power of 4, already here 16 means 2 to the power of 4. This is equal to 2 to the power of 8 into 9. 2 to the power of 8 into 9. Okay. So welcome back. See here clearly 2 power 8 is a even number, 9 is a odd number. Here multiply and divide with 2 power b. So this is equal to 2 power b by 2 power b by 2 power b plus 2 power c by 2 power b is equal to 2 power 8 into 9. Understand? So this is equal to 2 power into 1 plus 2 power c by 2 power b is equal to 2 power 8 into 9. Clearly 2 power 8 is an even number, this is also an even number. 2 power 8 is equal to 2 power b, therefore b is equal to 8. Here a is equal to 4, b is equal to 8. Definitely this is an odd number. 2 power c minus b means even number plus 1 odd number. That is 1 plus 2 power c by 2 power 8. Already 2 power 8 no, so this is equal to 2 power 8 is equal to 9. 2 power c by 2 power 8 is equal to 8. So this is equal to 2 power c is equal to, so this is equal to 8 means 2 cube. Again 2 power 8 will come, so this is equal to 2 power 11. C is equal to 11. So therefore a is equal to 4, b is equal to 8, c is equal to 11. So like that we have to prove. So this is one of the maths Olympiad problems. So from this problem what the conclusion we have to get means, so the number of unknowns should not, sometimes may not be equal to number of equations. Here given one equation, we are able to find out the values of a and b and c. All the three values we are able to find out. Okay, na? So I hope that you understand this maths Olympiad problem. Also you enjoyed today's class also with some more problems. Tomorrow's class I will stand before you. So until then, all the best for your April attempt. Okay, na?